By the end of this session, you'll be able to apply Newton's 3 laws to a variety of situations. You'll be able to correctly use F equals ma, and you'll know that force is rate of change of momentum. Remember, we've come across momentum before. So, what was Newton's first law? These are translated from the original Latin, because I thought there probably weren't too many people that could read the Latin. So Newton says, every body continues in its state of rest or uniform motion in a right line unless it's compelled to change that state by forces impressed upon it. Which is quite a mouthful. What that really means, or what we would think now, is that if a body's moving, it carries on moving, or if an object's at rest, it stays at rest, unless its movement is changed by a resultant force. So, let's think about that. In some ways, the reason we think Newton was so clever is that Newton's laws are counterintuitive. They're not what we think about, not what we know from everyday life. For example, when a car's driving up a hill or driving along, in order to keep it at a steady speed, you have to keep your foot on the accelerator. If you take your foot off the accelerator, the car slows down and stops. So, we often think that if we're going to keep an object moving, we have to apply a force. But Newton's first law says that that isn't the case. Newton's first law says that keeping moving is the rule and the stopping is the exception. And we don't see that. What about when you kick a football? You kick the football, it rolls. If you're a good footballer, it rolls a long way. If you're not very good, it just trickles along the floor and stops. But it stops. We've applied a force and the ball stops. But Newton's first law says that it shouldn't. How come? Well, the reason is we have to think about the resultant force. We have to think about all the forces that are acting on this object. Now, we've looked at free body diagrams already, where we draw all the forces acting on a body. And if we think about the example of the car again, well, yes, to keep the car moving, I have to keep the foot on the accelerator, but that's because there's always friction. There's another force that we don't think about. And quite often, the reason that Newton's first law doesn't seem to work is because we haven't taken into account friction or air resistance. They often provide an extra force that slows things down.